In this video, we will going to take up the problems on the shortening or extension of the length of the bar. The problem number 1, it reads as a steel bar of 2 meters long and 150 mm square is cross section is subjected to an axial pull of 15 kilonewton. Find the elongation of bar. Take the Young's modulus E equals 200 GPa. So what are all the data given? The data given as the length of bar is 2 meters. So convert that into mm because all other dimension is given in mm. So the area of cross section is given as mm square. So you convert 2 meters into mm. So that is 1 meter is equal to 1000 mm. So that is 2 into 10 to the power of 3. So that will be equal to 2000 mm. Then area of cross section of the bar, capital A, will be equal to 150 mm square. Is subjected to an axial pull. Since it is the tensile load what he has applied, P is equal to 15 kilonewton. And I will convert that into Newton, 15 into 10 to the power of 3 Newton. So then E, Young's modulus E is given by 200 GPa. So 200 gigapascal is converted into Newton per mm square. So first convert that into Newton per meter square. 200 into 10 to the power of 9. Giga means 10 to the power of 9. Pascal, 1 Pascal is equal to 1 Newton per meter square. So therefore you will going to get it as 200 into 10 to the power of 9 Newton per meter square. But here all the dimensions are taken in mm. So this is in mm and the area is in mm square. So you convert this into mm square. To do that, 200 into 10 to the power of 9 divided by 10 to the power of 6. So on simplification, you will going to get it as 200 into 10 to the power of 3 Newton per mm square. So in general, if I say 200 GPa, I can directly write it as 200 into 10 to the power of 3 Newton per mm square. So what is 1 GPa? 1 GPa is nothing but how the conversion takes place, which we have been elaborated only once in this particular problem because this is the first problem. We are explaining in detail. 1 GPa equals 10 to the power of 9 Newton per meter square. So 10 to the power of 6 Newton per meter square will be equal to 10 to the power of 6 by 10 to the power of 6. So you will going to get it as 1 Newton per mm square. So that will be 10 to the power of 6 Newton per meter square will be equal to 1 Newton per mm square. So then what is the stress? Stress is nothing but load by area of cross section, which is axial pull by area of cross section of the bar. Since it is the axial pull which is P by A, so the load what he has given is 15 kilonewton. So substitute the value of P as 15 into 10 to the power of 3 divided by the area of the cross section of the bar is 150. By calculating this, you will going to get it as 100 Newton per mm square. Then what is Young's modulus? Young's modulus is nothing but E, which is equal to stress by strain, which is equal to sigma by epsilon. You know the value of Young's modulus and you know the value of stress. So epsilon can be easily found out. So substitute the value of Young's modulus as 200 into 10 to the power of 3 is equal to value of stress as 100, which is the calculated value, by epsilon. Therefore, epsilon will be strain, which is equal to 5 into 10 to the power of minus 4. So once you get this strain, then also we know epsilon will be equal to change in length by the original length. So that is nothing but delta L by L. You know the value of epsilon, you know the value of length, therefore you can find out the delta L by L. So substitute the value of strain, which is calculated as 5 into 10 to the power of minus 4, which is equal to delta L by the length of the original length of the bar as 2000. So once you on calculation, the change in length or elongation of the bar, delta L will be equal to 1 mm. So this is the how it will going to be followed. But we have a shortcut method wherein you have the elongation of the bar is given by delta L, which is equal to capital P into L by capital A into capital E. So you know the value of P as 200 into 150 into 10 to the power of 3, and the length of the member as 2000 divided by area of cross section, which is 150 into Young's modulus is 200 into 10 to the power of 3, which is equal to 1 mm. You will go to get this value directly. Either this way or either this or that we can be followed. This can be obtained directly from the formula. Now, delta L will be equal to 1 mm. Now we'll go for the one more problem. So the problem number 2. An alloy bar of 1 meter long and 20 mm by 10 mm in cross section is subjected to a compressive load of 20 kilonewton. If the modulus of elasticity for the alloy is 100 GPa, find the decrease in length of the bar. Since the load applied is compressive, naturally there will be a decrease in length of the bar. So that is the reason why he says it is find the decrease in length of the bar because of this compressive load. So what is the length of the bar, which is 1 meter, which will be equal to 1 into 10 to the power of 3 mm, which will be equal to 1000 mm. Then the compressive load P, which is 20 kilonewton, which will be 20 into 10 to the power of 3 Newton. Similarly, modulus of elasticity is 100 GPa, which is equal to 100 into 10 to the power of 3 Newton per mm square. Then the area of cross section bar A will be equal to 20 mm by 10 mm, which is equal to 200 mm square. Then find the decrease in length of the bar. So according to the formula, decrease in length or the shortening of bar is delta L, which is equal to P into L by A into E. Since you have all the values, you substitute those values, finally you're going to get the answer. P is 20 into 10 to the power of 3 into length is 10 to the power of 3 or 1000 divided by area of cross section is 200 into 100 into 10 to the power of 3. On simplification, you will going to get the shortening of the bar as 1 mm. This is how you will be able to solve this problem. If you find this, this is how you will be able to solve this problem. And if you like this video, please subscribe to my channel. Thank you very much.